Welcome back. Now we start working on problems from webwork, section 7.4, integration of rational functions by partial fractions. Problem 1. Which of the following is the correct form of the partial fraction decomposition of 2x over x plus 3 times 3x plus 1? Notice 2x over x plus 3, 3x plus 1. These are distinct linear factors. Distinct linear factors. That is, they are different linear factors. So you have constant over first factor plus constant over another factor. Okay. So that's the correct form of partial fraction decomposition. So a over x plus 3 plus b over 3x plus 1. Check. Correct. Next problem. Which of the following is the correct form of the partial fraction decomposition of 1 over x cubed plus 2x squared plus x? 1 over x cubed plus 2x squared plus x. We need to factor the denominator. You notice x is common. When I pull out x common, I'm left with x squared plus 2x plus 1. This is a complete square, x plus 1 quantity square. So I have one linear factor here and I have another linear factor which is repeated. It has a higher power than 1. In other words, I have one constant for x and I have two constants for x plus 1 and x plus 1 squared. So this is the correct partial decomposition. Okay. Here. Next. Which of the following is the correct form of the partial fraction decomposition of x minus 1 over x cubed plus x squared? X minus 1 over x cubed plus x squared. So I need to factor the denominator. Notice x squared comes out common. What's left is x plus 1. Now here x is linear to the power 2. So one factor, linear factor, power 2. So that gets me a constant for x and a constant for x squared. And x plus 1 is a linear factor of power 1. So only one constant. So this is the correct format here. Next. Which of the following is the correct form of the partial fraction decomposition of x minus 1, x cubed plus x? X minus 1, x cubed plus x. Now here x is common factor. When I pull out x common, I'm left with x squared plus 1. Numerator is x minus 1. So that is a linear factor appearing only power 1. So a constant over that x. Now this is irreducible. That is, I cannot factor with x squared plus 1. So this is the quadratic. So each numerator is going to be bx plus c. Okay, 1 degree less. So a over x plus bx plus c over x squared plus 1 is the correct form of the partial decomposition. So a over x, bx plus c, x squared plus 1. Next. Problem 5. Which of the following for 2 over x squared plus 3x minus 4? 2 over x squared plus 3x minus 4. The denominator factors into linear factors, distinct, that is different linear factors. So I have a constant over one factor plus a constant over another factor. What are the factors? X plus 4, x minus 1. X plus 4, x minus 1. So constant over x plus 4 plus a constant over x minus 1. Next. Which of the following? For 2x plus 1 over x plus 1 power 3, x squared plus 4 power 2. Notice power 3 means I'm going to have three constants. One for x plus 1, one for x plus 1 power 2, and one for x plus 1 power 3. Here x squared plus 4 is irreducible, so I'm going to have a linear numerator twice. Okay, so let's see. Constant for x plus 1, constant for x plus 1 power 2, and a constant for x plus 1 power 3. Whereas for this, I'm going to have a linear polynomial above. So dx plus e, two constants to worry about. One for first power, another pair for power 2. Okay. So constant for x plus 1, constant for x plus 1 squared, constant for x plus 1 power 3. Then here a linear numerator, that is a pair of constants, and another pair of constants. So it's this. Next. Evaluate the integral 9x over x minus 6. Okay. 9x over x minus 6. So notice this is an improper rational, that is you can divide it. I have simply said negative 54 plus 54. Why did I do that? You see 9 comes common. Okay. So x minus 6 divides to each one. You get 9 plus 54 over x minus 6. So notice you could have used long division. You would get the same answer. Quotient, remainder, divisor. Okay. So integral of 9 is 9x. Integral of 54 over x minus 6 is 54 times natural log x minus 6. Do not forget constant of integration. So let's move this here. Let's check it. 9x plus 54 natural log absolute value x minus 6 plus c. Good. Next, evaluate the integral 6r squared over r plus 4. 6r squared over r plus 4. Okay. You could divide using long division. 6r squared over r plus 4. You will get 6r minus 24 as the quotient plus 96 over r plus 4 as the 96 as the remainder. Okay. If you do not understand what I mean here, let's try doing this by hand. Right? So what I'm saying is use long division. So in the previous case also we did long division. Here also I did long division. So let me explain for a minute what I mean. In the previous case, was the long division there? Division is like this. Numerator goes inside. Denominator is outside. Okay. There is no constant term, so I just write plus 0. X, I'm looking at leading coefficient, coefficient. X goes in 9x 9 times. Now multiplying 9 times x is 9x. 9 times negative 6 is negative 54. What do we do in long division? We subtract the second line from the first line. Subtraction means change of signs. So these two cancel. I have 0 plus 54. So 54 is my remainder because x is degree 1. This has no x, so I stop. So that's the quotient and that's the remainder. I'm still not finished, so 54 over x minus 6. So that's how you obtain these values. Likewise, here, let's look at the next one, right? 6r squared is the numerator. So 6r squared is being divided by r plus 4. Okay, so this has no r, so 0r, and no constant, so 0. So this is how we perform long division. R goes in 6r squared, 6r times. 6r times r is 6r times, so that's what we try to do. We try to match. 6r times 4 is 24r. And what do? We subtract the second line from the first line. These go away. I'm left with negative 24r. Okay. Now r, to match with negative 24r, I need a negative 24. So that gets me negative 24r negative 24 times positive 4 is negative 96. You'll have to trust me. Take my word for it, right? So I'm out of space here, so let me quickly go with this. When I subtract, you essentially change signs. These cancel and we are left with positive 96, which has degree less than r plus 4, so that's your remainder. So the remainder continues and the quotient is 6r minus 24. So the quotient first plus a remainder that's not yet finished division, so you still have to write the denominator. Now this part is polynomial. Its integral is, integration of 6r is 3r squared. Integral of 24 is 24r. Integral of 96 over r plus 4 is 96 natural log r plus 4. Do not forget constant of integration. So let's put it all in. 3r power 2 minus 24r plus 96 natural log absolute value r plus 4 plus constant of integration. That's correct. So we'll continue from on problem 9 in our next video.